Hi, and welcome back to Psychology with me, Mr. Snyder, and today we are going to delve into the world, ever so briefly, of classical conditioning and begin our chapter on learning and language development. Your learning targets today are to talk about the aspects and characteristics of classical conditioning, talk about the most famous experiments of classical conditioning, and talk about how it can apply to everyday life. So, first of all, let's go ahead and define learning. Learning is a relatively permanent change in behavior that can be brought about by experience or practice. And so, if you think about it, whenever you learn something new, some part of your brain is physically changed, whether on a neurological level, to record what has been learned. And so, basically, it is a physical change in your brain that is brought about by learning something or going through some experience or practice, and coming out different on the other side. And so this, if we're talking about a change in the body, and so if you're basically how you're brought up and how you are physically matured, if that is controlled by your genetics, then we call that maturation. Classical conditioning is a form of learning. Condition is just another word for learn. And so Ivan Pavlov is a Russian physiologist who studied the classical conditioning through his work in the salivation and digestion of dogs, and he accidentally discovers classical conditioning and goes down in psychology history. Classical conditioning is learning to elicit, I'm just going to read this straight out and then we'll give you the real definition. Learning to elicit an involuntary response to a stimulus other than the original natural stimulus that normally produces the response. Sound confusing? It does to me. So, basically, classical conditioning is learning by pairing things together. So let's go ahead and take a look at this. Let's get some definitions first. The response or the reflexes that happened are unlearned involuntary responses. So if I shoot you in the eyes with water, what's going to happen? What is your automatic response? It is to blink or flinch. You're not going to notice. You're not going to have to learn to do that. That is involuntary reflex. A stimulus in this instance is any object, event, or experience that causes the response, and the response is the reaction that happens. Okay, so in classical conditioning, you're going to have to understand 5 things: the unconditioned stimulus, the unconditioned response, the neutral stimulus, the conditioned stimulus, and the conditioned response. That's 5 things that you'll have to identify out of situations that I give you, but I can help and narrow it down to 3 things if you can listen to some tips I'll give you in a second. So UCS and UCR, we'll call them, the unconditioned stimulus and the unconditioned response. You might see US and UR, it's the same thing. Unconditioned means unlearned. It's something that you don't have to learn. So an unconditioned stimulus is a naturally occurring stimulus that leads to a reflex or an involuntary response. The unconditioned response is the response to the naturally occurring unconditioned stimulus. Pardon me. The neutral stimulus is something introduced into the situation that has no effect. There's no response to it. Then when we get to the conditioned stimulus, this is something that is able to produce a learned response by being paired with the original unconditioned stimulus. And if that sounds confusing, just get the definitions down and we'll walk through what they mean. And it's important to know, this is one of the tips that I'll introduce in a second, the neutral stimulus will become the conditioned stimulus when it is paired with the unconditioned stimulus. And then the conditioned response is a learned reflex response to a conditioned stimulus. And it's sometimes called a conditioned reflex. We're just going to call it a conditioned response for our class. So some tips to analyzing the situations and identifying each aspect of classical conditioning. If you want to star these or draw arrows between them, you have to know that the UCS and C, that's wrong, sorry. The UCR and CR are always the same. And then the NS and CS are always the same. So the responses are always the same, and the NS and CS are always the same, because the neutral stimulus will become the conditioned stimulus. Here are some other classical conditioning tidbits that we've learned throughout the years. We already talked about the CR and the UCR are essentially the same. The only difference is what they are in response to. The unconditioned stimulus is always followed by an unconditioned response, and the conditioned stimulus is always followed by a conditioned response. So let's take this and talk about some more definitions before we get to the story. Or you know what? I'm going to go out of order, and I want to talk about the story. Let's apply this to the famous dog salivation experiment. Basically, the NS, and if you want to screenshot this, I recommend it. The NS in this situation is the bell. Before conditioning takes place, conditioning means learning, means pairing things together. The bell causes no salivation from the dog. He wonders, why are you ringing a bell in my face? Then during conditioning, the neutral stimulus, the bell, is paired with the unconditioned stimulus, which in this case is food. The dog does not have to learn to salivate when presented with food. It happens. So the salivation is the unconditioned response in this instance. And then after conditioning, the bell itself will elicit salivation. So the conditioned stimulus, in this instance the bell, used to be the neutral stimulus, now becomes the conditioned stimulus. By itself, it can bring about salivation, because the dog knows, the dog has learned that the bell is paired with food. Now let's go back and talk about some other situations. Here we go. The repeated pairing of the bell and the food in the dog instance is called acquisition. So we're acquiring the pairing. We are realizing that this is happening and that one is going to bring about the other, or that they're paired together. Stimulus generalization is another aspect you'll have to know, and that is the tendency to respond to a stimulus that is only similar to the original conditioned stimulus with a conditioned response. So would the dogs respond to any type of food? Would it only respond to dog food? Would it respond the same way to cat food? These are all instances, these are all ways which we can find out whether or not the stimulus is generalized or not. Stimulus discrimination in this case is basically what would it not respond to. The tendency to stop making a generalized response to a stimulus that is similar to the original conditioned stimulus, because the similar stimulus is never paired with the unconditioned stimulus. Okay, and then we have extinction and spontaneous recovery. Extinction in this instance is the disappearance of a response following the removal of the unconditioned stimulus. So if I did not present the food to the dog and I just kept ringing the bell, how long would it take for the dog to realize, okay, there's no food coming with the bell anymore, and it's going to stop salivating? In spontaneous recovery, this is if I would start ringing the bell again and presenting food. It would take less time to realize that, okay, he's going to start giving us food again with the bell. I'll show you on a chart here in a second. So there is the classical conditioning chart and the story at the bottom, how it happens if you need to see it again. This is an example of a stimulus generalization experiment. The galvanic skin response, or the CSR, is how we'll measure anxiety in this experiment. And the stimuli 0, 1, 2, and 3 are all different tones. On tone 0, they would get an electric shock. So that would cause anxiety, and that is how we would measure it with the GSR. And so when tested with the original tone and with tones 1, 2, and 3 of the other differing frequencies, a clear generalization effect appeared. The closer the frequency was to the original tone that they knew they were going to get shocked on, the greater the magnitude of the GSR to the tone. So you can see that on this curve here. 0 is when they're getting shocked. 1, 2, and 3 are differing tones. Generalization occurs. This is an example of spontaneous recovery and extinction. So during this period right here, you can see the acquisition period where we're presenting the bell and the food together. At first, there's not a strong salivation, but now they realize, okay, the bell is following food, or the food is following bell, so we're going to learn and respond a lot. Now, extinction occurs when we take away the food. If we just present the bell, you can see the salivation drops off rather quickly. Okay, we know no food is coming. Boom, rest, no training. Maybe the next day we present the bell and the food together again. Oh, okay, there is already a higher response. This is an example of spontaneous recovery right here. We already know that, okay, we've seen this pairing before, we know what's going to happen, and then extinction occurs at the relatively same rate. How conditioned emotional responses is what happens in the little Albert experiment. So it's an emotional response that is classically conditioned to occur to learned stimuli, such as a fear of dogs, or when you see an attractive person, you get that feeling. That has been learned. CERs may lead to phobias in real life. So one behaviorist would say that phobias and being scared of something is learned, and therefore it could be unlearned. But an irrational fear response to a general everyday object is a phobia. And then vicarious conditioning is learning a reflex or response by watching the reaction of another person. And I believe the example your book gives you is going to school, and there was a long line of kids waiting to get a vaccination at the end, and they would see how bad it hurt by watching the other kids, and the other kids cried. So pretty soon as the kid got up there, they would just immediately start crying because they knew how bad it was going to hurt, even though nothing had happened to them. They learned to be afraid of it by watching other children. That's vicarious conditioning. Here's the little Albert experiment. So Albert was a kid. Basically, he was in the hospital, I believe, for a while, spent most of his young days in the hospital, so he didn't have a lot of outside experience. So anything presented to him, he was interested in it. He would want to touch fire. They also presented a little rat to him, just a white laboratory rat, and he wasn't scared of it. It actually caused him pleasure, and he liked it, and he tried to play with it. But now, every time he played with the rat, John Watson would hit a bar behind him with another bar and create a huge loud sound, which babies are afraid of. So he paired the unconditioned stimulus, the rat, with the unconditioned stimulus in this instance is the bar, which causes the unconditioned response, fear. The rat then is paired with the loud sound, pretty soon to where you put the rat in front of Albert and he screams and cries alone. So the neutral stimulus, the rat, becomes the conditioned stimulus, the rat, which causes the conditioned response, fear, crying, anxiety, because he thinks the sound is going to come. And then he also generalizes this to other white furry things. You can see the Santa Claus mask here that Watson is shoving in his face. A white fur coat, a rabbit, a dog. He was generalizing it to all of these things. So very unethical experiment, would not be allowed today, but did give us some insight into the little Albert, basically how conditioning works. And how do we use conditioning today, you and me? Well, have you ever gotten food poisoning and then not ate at that place ever again? That's an example of a conditioned taste aversion. You develop an aversive response to a particular taste because that taste was followed by nausea reaction. In college, I ate hot food at Dairy Queen one time, so instead of ice cream, I got a hamburger, and I got violently ill, and I have not been back to Dairy Queen for hot food since then. I'm sure it's perfectly safe. I'm sure Dairy Queen is a fine establishment, but I will not go back there just because of the emotional response that happened after that, the nausea that I went through. And that is biological. That is an example of animals being biologically prepared because they can learn certain associations through only one or two trials or pairings because there is survival value in that. If you eat a berry, or if our ancestors ate a berry and it made them violently ill, and they went back and ate the same berry, there's less chance that they would survive. So learning that over time, that you shouldn't eat that berry anymore, has survival value in that. And that's a little look at conditioning. If you have any questions, please bring them back to class, and I will talk to you later. Bye-bye.